Hello, good afternoon. My name is Miles Miller. Today I'll be presenting my math and chemistry PoL, and I'll first start off with math. For math, this is my homework completion chart, and I did try to get most of my homework done. And this is my assessment score chart, and I did do my corrections for quiz 1, and then for quiz 2 I didn't do my corrections, and then I think if I did my corrections for quiz 2 I probably would have got a higher score on my test part 1 and 2. To improve what I did to improve my grade, I asked my peers for help and to see if they can help me or to see if they can explain it for me to understand it. My effort wasn't the best this semester for math because I didn't get in most of my homework and I didn't do my test corrections. And I think if I did that, then I would have a better grade. My first learning target is 2.3, and the quiz and test I'm gonna be comparing is quiz number 2, question 6, and test 1, part 2, question 3. So for this one, I didn't show my work, nor did I justify it. So that's why it's wrong. And same thing with this one, I didn't justify or show my work. So that's why that's wrong. For learning target 2.4, I chose quiz 2, question 7, test 1, part 2, question 4. And here I didn't solve for y and z correctly, but I did solve for x correctly. And I think because I didn't show my work, that's why it's wrong also. And I didn't do my math correctly. And this one I didn't justify or do my math correctly because I didn't really practice this problem. So that's why that's wrong, basically. The reason why I have the grade I have today is because of my effort in putting in work and doing the test. And I think if I put in more effort and ask more questions about the problems and works, or the work, I would have got a better grade. Moving on to chemistry. So chemistry, I didn't do so well in Unit 2, which was about atomic theory and nuclear reaction. So the first one is the nucleus of an atom, which is basically just neutrons and protons. And the atom is mostly empty space, and on the outside it's electrons. For the discovery of the electrons in the nuclear atom, J.J. Thomson just used the cathode ray experiment, which was a vacuum tube. He shot an electric current through a thin piece of foil, and the atoms split, and he discovered electrons because they went to the top, and he had a positive charge on the top and a negative charge on the bottom, and they went straight to the top. This is the Rutherford experiment, or the gold foil experiment, and he shot positive particles through a gold piece of foil, and when the particles went through, they reflected off and bounced off. 1% of them did, and then 99% went through. And Chadwick, which is the other one, he basically discovered alpha, beta, and gamma. For this one, which is the protons and neutrons in a nucleus. Sorry, it's kind of yeah. Um, Basically, the more protons you have in the nucleus, the more force you have in the whole nucleus. If you have more protons. For isotopes, it keeps the same amount of protons but changes the neutrons. So the electrons stay the same and the atomic number stays the same and atomic mass gets bigger. For this one, it's the three most common radioactive particles, which is alpha, beta, and gamma. Alpha rays can be stopped by a thin sheet of paper. Beta particles can be stopped by cardboard, and gamma rays can be stopped by lead or concrete. This basically concludes my math and chemistry video. Any questions?